Well, welcome to Chapter 9. This section, we're going to talk about translations. And translations are a type of transformation. And what a transformation is in a geometric figure, it's just a change in the position, shape, or size of the figure. And there's an example here of dominoes. It says when you play dominoes, you often move the dominoes by doing several different things. You might flip the domino, you might slide the domino, you might turn the domino. And every one of those moves is called a transformation. Okay, these kind of show you the different transformations that we will study. And the original figure is called the pre-image. So before you do anything to it, this would be a pre-image, whereas then this one becomes the image. The resulting figure is the image. And another word that you're going to see is called an isometry. And an isometry is a transformation where the pre-image and the image are congruent. So no matter what you do to it, the thing stays congruent. And remember, congruent means all the sides and all the angles are equal in measure. So let's take a look and figure out how we identify whether something is an isometry. It says, does the transformation at the right appear to be an isometry? So this is what we start with. This is a pre-image, and this is what we end up with, the image. Are these two figures congruent? And the answer is no. The sides are not the same length. It has changed in size. Not only has it moved, but it got bigger. Okay? So these would be similar figures, but they are definitely not congruent figures. So that is not an isometry. How about these two down here? Letter A. Are these isometries? Does the transformation appear to be an isometry? And letter A looks like it is. Okay, it looks like all those sides are congruent, the angles are congruent. So I would say for letter A that yes, that one is an isometry. How about for letter B? Here's our pre-image, here's our image, and it looks like that was rotated and translated, and that looks also to be an isometry. They're the same size, same shape, so I would say yes, those are also an isometry. A transformation maps a figure onto its image, and you can describe this using arrow notation. So the prime notation here, that little prime, means that's what the image is. So in this example, we have triangle JKQ. Triangle J prime K prime Q prime is the image after a translation and a rotation. Okay, or actually after a translation and a flip, it looks like. So triangle JKQ maps onto J prime K prime Q prime. Okay, the thing to also make sure of is to put each of those points, vertices, in their corresponding position. So J has to correspond to J prime, K to K prime, and Q to Q prime. Very important, the order of the letters. So naming images and corresponding parts. It says in this diagram, E prime, F prime, G prime, H prime. This one is the image of the pre-image EFGH. What are the images of F, angle F, and angle H? Well, angle F, its image would be F prime, and angle H's image would be H prime. Okay, we can show that by the corresponding parts by drawing the arrows right here to the corresponding parts on the image figure. What are the pairs of corresponding sides? Well, those are all listed for you here. EF and E prime, F prime, and so on. Okay. Here's one for you to try. In the diagram, triangle NID is mapped to a triangle SUP. What are the images of angle I and point D? Well, since they gave us this mapping, okay, we know that angle I has to correspond to angle U, right? So I would say angle U for angle I. What corresponds to point D? Well, point D better correspond to point P, right? What are the pairs of corresponding sides? And those you can list out. So you could say NI corresponds to, let's see how we wrote that in the last one. Just want to get the right notation. Whoops. Okay, so we just wrote them with segments and the word and. So NI would correspond to SU. And let's see, ID would correspond to which side in the other one. That looks like it would be UP. And ND should correspond to SP, right? So those are our three corresponding sides. So here is a key concept for you of translations. A translation is a transformation that maps all the points of a figure the same distance in the same direction, and it is an isometry. Okay, so all you're doing is moving it. It's like a slide. Okay, it's like a slide from one position to the next. So here's a diagram that shows a translation in the coordinate plane, in the XY plane, and we have a square, ABCD, and each point of that black square is being moved 4 units to the right and 2 units down. So using variables, you can say that each XY pair, each coordinate pair in the original figure is mapped to an image. Okay, and the way that you're going to find the coordinates of the image, because it was moved 4 to the right, all of the x coordinates will be x plus 4. And it was mapped 2 units downward, so the y direction, each of the image coordinates for y, you will subtract 2. So the y prime becomes y minus 2. And so here's the notation how we would write that. So xy in the pre-image maps to x plus 4 and y minus 2. So that's the rule, the translation rule. That's what they're looking for if they say write a translation rule for the figure. That's what they mean. So let's do an example here. What are the images of the vertices of triangle PQR for this translation rule? So here's a translation rule. So x is going to go to x minus 2 and y is going to go to y minus 5, and then they want us to graph the image. Well, what is happening here? It looks like the x coordinate, you're decreasing it by 2, so in the x direction you're going left 2 units. And in the y direction you're decreasing by 5, so that's a downward direction, so it's going to go down 5 units in the graph. Okay? So first we have to identify the coordinates. So what are the coordinates of P, Q, and R? And I have those listed here for you. And then we want to find what the new coordinates would be after we do this translation to each of these coordinates. Okay, so it says we're going to subtract 2 from the x coordinate and subtract 5 from the y coordinate. 2 minus 2 is 0, and 1 minus 5 is negative 4. So P prime, okay, that's the image of P, would have these coordinates. Q prime will have the coordinates 1, negative 2. Remember, we're just subtracting 2 from x, subtracting 5 from y. And then R prime would have coordinates negative 3, negative 2. So now what we need to do is just go ahead and graph each of these 3 image points. So I've done that down here in blue. And all we need to do now is just connect those 3 dots. Once you have those 3 points, go ahead and draw in the segments, and then you have your pre-image PQR and your image P prime, Q prime, R prime. So here's one for you to try. Go ahead and pause the video. I've given you an original triangle ABC. You'll need to find its coordinates and then find the coordinates of the image and then graph that. And it talks about what relationships exist among the segments and how do you know. We'll talk about that when we come back. So go ahead and try that on your own. Pause the video and we'll talk when you get back. Alright, hope you gave that a try. Let's take a look. So it looks like A has coordinates 2, 8. Okay. B has coordinates, what is that, 5, 6. And C has coordinates 3, 4, right? Okay. So we have those 3 coordinates. Here's the transformation we want to do. So what would the coordinates of A prime be? I'm going to do this one in a different color, just to kind of make a difference here. Let's do this one in blue, okay? We'll do A prime. Now what are we doing to the x coordinate? We're doing plus 1. So it was 2, so it's going to be 3. And what are we doing to the y coordinate? It's minus 4. So 8 minus 4 is 4. B prime. X coordinate we're adding 1, so that would be 6. Y coordinate we're subtracting 4 would be 2. C prime, add 1, we get 4. Y coordinate we subtract 4, we get 0. So then what we need to do is we need to go ahead and plot those points, 3, 4. So that's going to be, let's see, 3, 1, 2, 3, 4. Oh, that ended up in the same place, but this is actually this same point. Remember, this is going to be A prime now. A prime, I'll go ahead and list that on there. And 6, 2 is right here. And that's the point B prime, right? And then 4, 0 is the point C prime. Now remember, we need to connect those 3 segments. Let me get the right color here. Let's use this one. So A prime's up here. I want to connect A prime to C prime, and then C prime to B prime, and B prime back up to A prime. Okay, so there we have the image that was made by translating this 1 unit to the right and 4 units down. Writing a rule to describe a translation. What's the rule that describes the translation of PQRS to P prime, Q prime, R prime, S prime? Well, all you need to do these is to figure out how your coordinates changed, okay? And sometimes what you can do is just figure out, if I'm at P, how do I get to P prime? Well, you could just count how many units over did it move, how many to the right, and how many down. And so if you look at that, it went 8 units to the right. Our P and P prime coordinates are given, and the X coordinate started at -3 and ended up at 5, and that's a change of 8 units. The Y coordinate went down by 2, so X goes up by 8 and Y goes down by 2. So then writing our rule would be X plus 8 and Y minus 2. Alright, this is our second to last slide here. We're almost through. We have the translation image of triangle LMN is L prime, M prime, N prime. And these are the coordinates of the image points. What is a rule that describes the translation? Well, remember, when we're doing a rule, we want something like this. We want X comma Y in parentheses, and then we want an arrow, and then we want to say what's going to happen to X. Well, if we just look at any point here, how far is it from 1 on a number line to -6? And is it going up or down? Well, remember, this is what we start with, and this is what we end with. So it looks like we added 7. Okay, so how do we want to write that? Need to correct that. We should put our X coordinate in there, right? So we're going to go X plus 7. What about our Y coordinate? How did that change? Remember, we're starting with this one. This is the pre-image, and we're going to this image one. And that one went down by 1, so that's a Y minus 1. Then you should just double check to make sure that that's true for all 3 of these points. If we started at -4 and went to 3, how far did we go? Well, that's up 7, so that's good. And from -3 to -4 is down 1. If you look at your N coordinate, pre-image and image, we definitely went up 7 and we went down 1. So it works for all 3 of the points. Those are all accurate. So this is the rule that describes the translation. Okay, one more thing. A composition of transformation is just a combination of 2 or more transformations. So you could be sliding something one way and then slide it another way, or do a rotation, or different things. So here's an example in soccer. We could have this player 3 pass the ball directly to player 5. Actually, it's field hockey, sorry about that. Or we could have that player pass it to another player first, who passes it to player 5. So these are 2 different transformations that end up in the same position. So the composition of any 2 translations is another translation. Here is your lesson check. Go ahead and work on these 3 problems and bring your answers to class. See you next time.